Hello students, welcome to Ennapan Academy of Chemistry. Based on the request received from many students, today we are going to discuss repeated question models in the topic equilibrium taken from the past 25 years of NEET papers. Equilibrium topic is considered as a vast topic by most of you. It is true. But the good news is, if you look at the NEET question papers, questions frequently come from these 7 headings. Today, what we are going to do, from each model, we are going to work out 1 or 2 problems. If you look at the type of questions, most of the questions from equilibrium unit are numericals. 1 or 2 conceptual questions are also found. The headings we are going to see today are equilibrium constant, Chatelier Principle, acid-base strength, dissociation constant, pH, buffer, and solubility. This lecture will be split into 2 parts. In the first part, we will analyze the first 3 headings, that is equilibrium constant, Chatelier Principle, and acid-base strength. The remaining 4 headings will be discussed in part 2. Now, we can go to the questions. Look at the first question. For a given exothermic reaction, Kp and Kp prime are equilibrium constants at temperatures T1 and T2 respectively. Assuming that heat of reaction is constant in the temperature range between T1 and T2, it is readily observed that what is given here? It is given that the reaction is an exothermic reaction. This is the keyword. Then, at 2 different temperatures, T1 and T2, equilibrium constants are Kp and Kp prime. Okay. Now, you have to find out the relationship between Kp and Kp prime. That is the question. So, if you increase the temperature, exothermic reaction will not be favored. So, the equilibrium constant value decreases. So, the correct answer is option A. Kp will be greater than Kp prime. Look at the second question. This is also a conceptual question. If the value of equilibrium constant for a particular reaction is 1.6 into 10 power 12, then at equilibrium the system will contain. This is a straightforward question. If the equilibrium constant value is greater than 10 power 3, if K is greater than 10 power 3, then the reaction will proceed to completion and the reaction mixture will contain mostly products. Now let us go to the next question model. The equilibrium constant for the reaction N2 plus O2 giving 2NO is K. The equilibrium constant for half N2 plus half O2 giving NO is. This question model is very frequent in the equilibrium constant heading. This question is about rearrangement of equilibrium constant. So, if the equilibrium constant of the first equation is K, then for the second equation, what is the answer? K power half. If you multiply throughout by a coefficient, you raise the equilibrium constant to the power. You remember these 3 points to answer this type of questions. I repeat. First point is, if you reverse an equation, take reciprocal of the equilibrium constant. Second point is, if you multiply an equation by a common coefficient, then raise the equilibrium constant to the power of that coefficient. Third point, if you are adding two equations, then you have to multiply the equilibrium constants. If you remember these 3 points, you can easily answer this model. These two questions are based on Kp-Kc relationship, where delta Ng is equal to number of moles of the gaseous product minus number of moles of the gaseous reactant. What is the first question? 4 options, 4 equations are given. Out of the 4 reactions, in which reaction Kp and Kc are not equal? That is the question. Okay. Based on this expression, Kp will become equal to Kc. Kp will be equal to Kc if delta Ng is equal to 0. Okay. When delta Ng will be equal to 0, if Np is equal to Nr. That is, in the reactant side and product side, number of moles of the gaseous species should be equal. Then delta Ng will be 0 and Kp will be equal to Kc. Out of the 4 options, in the first 3 options, see, look at the first option, 2 moles of NO, giving 1 mole nitrogen, 1 mole oxygen, 1 plus 1, 2. Second option, 1 mole SO2, 1 mole NO2. So, Nr is 2. Product side also, Np is equal to 2. Third option, option C, here also, Nr is equal to 2, Np is also 2. Whereas fourth option, option D, here you should not count carbon because it is in the solid state. You just count the gaseous species. 1 mole of oxygen. In the product side, you have 2 moles of carbon dioxide. So, in this case, Nr is 1, Np is 2. Therefore, delta Ng is not 0. So, Kp is not equal to Kc in option D. So, that is the correct answer. Now, coming to the next question. In which of the following cases, the value of Kp is less than Kc? Again, take the same expression. Kp is equal to Kc into RT power delta Ng. Take the same expression. Okay. What is the question? Kp should be less than Kc. When this will happen? It will be Kp will be less than Kc if delta G is negative. Okay. Delta G will be negative if number of moles of the product is less than number of moles of the reactant. Np is less than Nr. Look at the 4 options. Np is less than Nr in the case of option C. So, this is the correct answer. In this case, Kp will be less than Kc. So, this is also a frequent question model. If you remember this formula, you will be able to answer these questions. You have to be careful in one point. You should count only the gaseous products and gaseous reactants. This is another model. A reaction is given. For the above reaction, look at the first question. Temperature is there, 298 Kelvin. Kc value is given. If the concentration of oxygen at equilibrium concentration of the reactant is given, what is the concentration of the equilibrium concentration of the product? This is a straightforward question. To answer this question, just write the expression for equilibrium constant. Kc is equal to concentration of O3 power 2 divided by concentration of O2 power 3. Okay. O2 concentration is given. Kc value is there. Just substitute those values. Substitute those values and work out. You will get the concentration of O3 and you will get the answer as 4.38 into 10 power minus 32. Look at the next question. This is another model. Sucrose hydrolysis reaction is given. Equilibrium constant value is there. Temperature is given. You have to find the delta G naught value. You need not find the final value of delta G naught. Look at the options. You just have to find out the expression. That's all. The formula connecting delta G naught to equilibrium constant is delta G naught is equal to minus RT ln K. Okay. So the correct answer for this question is minus 8.314 into 300 into log 2 into 10 power 30. Don't confuse this K with the equilibrium constant. This is Kelvin, unit of temperature. Don't get confused. This is the correct answer. These questions are direct questions, mostly concept questions. Look at the first one. KMnO4 can be prepared from K2MnO4 as per the reaction. Reaction is given. The reaction can go to completion by removing OH minus ions by adding. Okay, 4 options are given. According to Chatelier principle, you know, if you remove OH minus ions, then this reaction will proceed in the forward direction. To remove hydroxide ions, we have to add an acid. So option A is ruled out. It is a base. KOH is a base. So the correct answer is either B, C or D. Out of the 3 options, all 3 are acids. Okay. But HCl and SO2 are also reducing agents. The given reaction is an oxidation reaction. So we have to add an acid which will only remove the OH minus ions without affecting the reaction. Okay. So you cannot add reducing agents to an oxidation reaction. So the correct answer is carbon dioxide. CO2 will only remove OH minus ions without affecting the reaction. Okay. Look at the next question. According to Le Chatelier's principle, adding heat to a solid and liquid in equilibrium will cause. Okay. Solid liquid equilibrium is observed during melting process. When you heat a solid, you get the liquid. Okay. So this is an endothermic reaction. You have to supply heat to convert solid into liquid. So for an endothermic reaction, if you add heat, it will be favored. The reaction will proceed in the forward direction. So the amount of solid will decrease if you increase the heat during the melting process. You can look at the next question now. The common question model, repeated model under this heading, acid-base strength is, you will be given a set of acids or bases. You have to arrange them in the order of increasing or decreasing acidic character or basic character based on the strength. Look at the first question. In which of the following arrangements the given sequence is not strictly according to the properties indicated against it? Read the question carefully. What properties are given? Acid strength, pKa values, acidic character, oxidizing power. Okay. Look at the first option, HF, HCl, HBr, HI. Here fluorine, chlorine, bromine, iodine. These elements belong to the same group. As you move down the group, okay, we know that acid strength increases. This is correct. You have to find out the wrong statement. This is a correct statement. Option 1 is correct. Option 2. Here also oxygen, sulfur, selenium, tellurium. They all belong to the same group. Oxygen, sulfur, selenium, tellurium. Here also when you move down the group, acid strength increases. If acid strength increases, what happens to the pKa value? Okay, that you have to see. So acid strength is directly proportional to Ka, the dissociation constant of the acid. So it is inversely proportional to pKa. So down the group, acid strength increases. So pKa value should decrease down the group. So the second option, the statement given in the second option is wrong. That is the correct answer for this question. Okay, you need not look at third and fourth option because here itself we got the answer. So the second option is the correct answer for this question. Look at the next question. Acidity of diprotic acids in aqueous solutions increases in the order. Just now we saw oxygen, sulfur, selenium, tellurium. Here also H2S, H2SE, H2TE. If you move down the group, acid strength increases. So option 1 is the correct answer for this question. Look at the third question. This is also of the same model. Among the following, the correct order of acidity is HClO, HClO2, HClO3, HClO4. What is the difference? The oxidation state of chlorine increases from HClO to HClO4. Okay. If the oxidation state of the central atom, that is chlorine, increases, what will happen? It will pull the electrons present in the oxygen atom towards itself. As a result, the H plus attached to the oxygen atom will be easily released. So the conclusion is acid strength will be directly proportional to the oxidation state. Based on this, option 3 is the correct answer for this question. So we have completed the first 3 headings: equilibrium constant, Chatelier principle, and acid-base strength in this lecture. In the second part of the lecture, we will be looking at the remaining 4 topics. Okay. So here we have worked out only 1 or 2 problems from each model. If you want to access the complete set of solved problems along with easy revision notes, shortcuts, a formula to remember, everything is given. You can just follow the links provided. Right now, 5 topics are available from physical chemistry part for your NEET preparation as well as for your class 11 and 12 preparation. Make use of it. I hope you definitely enjoyed this video. Okay. You can subscribe to the channel for more updates and click the bell icon to receive the latest notifications. All the best for your exam preparation.